Okay, so welcome back. This is part 7 in our ongoing series where we help you to understand the wonderful world of 3D computer graphics. And I encourage you to look at the previous videos. We showed you how to set up and install and do some basic modeling using a wonderful and professional grade and very free and open source software called Blender. And it allows you to do stuff like you see here. In the last video, I showed you how to build this room structure with the windows and the walls and the floors and the ceilings and the door. And in fact, I built everything you see here from scratch in Blender. All of these little devices, the chairs and the computer and the monitors, I built them all from scratch and put materials on them and did the lighting. And you can do all of that in Blender. You can even do this animation. And here is a rotating animation you can do, and this is all done from scratch in Blender. And Blender is wonderful. It allows you to do this plus a bunch of other stuff. So I encourage you to look at the previous videos and try to start thinking about making stuff yourself. Do modeling yourself, do texturing and do animations yourself. Don't just download somebody else's work. Don't just copy and paste, but do it yourself. It'll be much more interesting and you can learn some stuff. So what we're going to do in this video is we're going to talk about a couple extremely important aspects of the 3D computer graphics world that you're really going to have to understand. A lot of people just want to say, what buttons do I press to make the next Star Wars epic? Well, really, if you want to become knowledgeable about this stuff, you're going to have to learn some of the basics. And a lot of people kind of discard the basics just so they can make a cool explosion, but it's really important that you actually learn stuff. And what we're going to talk about in this video is two critical components. One is colors, as you see here, and we're also going to talk about images, because much of what you do in the 3D computer graphics world is based on colors and images. And you're going to have to really understand the two if you're going to do anything in 3D computer graphics. And it can get a bit complicated, so we're going to try and make it very simple for you to understand these basic aspects. And then when you go ahead and look at things in the future, like materials and surfaces and lighting, it will make a whole lot more sense. And then you don't have to rely on somebody else to tell you what buttons to press. You can do it because you know how this stuff works. So here we are in a graphics program, and this is called Affinity Photo. You can use GIMP or whatever. And it is displaying on my monitor an image, and the image has a lot of colors. So let's first talk about colors. One of the challenges, and we've talked about this before, when dealing with computers is computers are stupid, right? Computers don't know anything. You have to tell a computer absolutely everything and be very specific about it. And that's certainly true when it comes to colors. We can look at this image and say, oh, that's got a lot of beautiful colors. Over on the left, it's got orange with the sun and yellow. On the right, it's got blue up in the corner here. It's got green in the forest, and it's got many, many colors. Probably got millions of colors. We could say, hey, computer, draw me orange, and it doesn't know what orange is, right? We have to be very specific and tell the computer what the colors are. So, if you show this image to 100 people and ask them what each of the colors are, you're probably going to get 200 responses, because even we don't know what these colors are, right? It's very complex. I mean, what color is over near the sun? Well, it's kind of a mixture of blue and orange. And so if we don't even know what the colors are, it's going to be a challenge trying to figure out how to explain that to the computer, because at the end of the day, the computer has got to put the color on the screen to represent this image. So how do you possibly take all of these millions of colors and then convert them into something the computer understands? Well, we've talked before that the computer understands nothing but numbers. In fact, computers only understand ones and zeros, called bits. So everything here has to be converted into bits, ones and zeros. A 1 is a high voltage and a 0 is a 0 voltage. So somehow we're going to have to convert all of these colors into ones and zeros, or numbers that the computer can understand. And we're going, for every color here, we're going to have to be very specific and say, here's a number, computer, to represent that color that I want to see on the screen. And since with 3D computer graphics, we're going to be doing a lot of generating images and making colors on different objects to represent the real world colors. So we're going to have to really understand how we can tell the computer what colors are, right? So the challenge is, how do we take these millions of colors and convert them into real world numbers? So if you give it some thought, you might be stumped, right? Kind of challenging to figure out how to specify what each of these colors is. Thankfully, there is a universal law that says that any color you can think of can be recreated by mixing 3 colors together in various amounts. And that really turns out to be a wonderful thing. We can come up with any color we want, and we can specify what that is merely by specifying how much of 3 colors are combined together. So for example, I've got 3 lights here in my scene, and this is Blender. I can mix those 3 lights together. One is red, one is green, and one is blue. I can mix those lights together in varying amounts, and I will get down here, they will all mix together to get whatever color I want. So for example, I can say, I've got my red, I've got my green at maximum, my blue at maximum. I could go to my red light and crank that down to 0, and now I have green and blue, and you can see it mixes together to give me another color, which is cyan. And I can vary these light components to get any color, mixing those lights together to get any color. All I need to do is specify how much intensity for each of those red, green, and blue components. So now all of the colors that we see here become merely 3 numbers. And those numbers are how much red, how much green, and how much blue. So that's really kind of wonderful. I can say, well, whatever this color is of this mountaintop, I can specify it as 3 numbers. So now we've got the image here, and what I can do is I can go to any point in this image, and I can select the color, and I can figure out what are the red and green and blue components. So what I will do is I will take this eyedropper here, and I'll go over here near the sun, and I will select it, and that right there on that square shows me the actual color of that point in the image. And I can find out what the values are. To get that color, to get that orangey color, I need 0.565 red, 0.565 green, and 0 blue. All right? So whatever color I get, I can break it down into 3 simple numbers. I can do that again. I can go and select this blue here in the corner, and you can see here's the blue, and that is 0.037 red, 0.122 green, and 0.275 blue. So you can see it's mostly blue with a little green and very little red. And I can go to any point in this image and come up with these 3 component colors. Again, very, very, very important, because now we can say, hey computer, 0.037, 0.122, 0.275, that's my color. And the computer can say, oh, yeah, I know what that is. That's easy. So really very nice and useful way to figure out what the colors are. You can break it down into its components. Now, as you can see here, the values go from 0 to 1. So I can crank up this to 1, the blue up to 1, and it gets bluer. And I can crank the green up, and it gets greener. Now the green is up at maximum 1. I can crank the red up, and it's at a maximum of 1. And what color do I get? I get white. Oh, so I can mix all of those together, those colors together, if they're all at maximum, and I will get white. And if I move them all down so they're at 0.5, I'm getting like a gray. And if I move it down so they're all at 0.1, I'm getting a darker gray. And if they're all at 0, you can imagine here's 0 and it's black, right? So I have specified any color in this image, or any color I can think of, by 3 numbers. And in this case, we're going from 0 to 1. So you get a lot of little decimals between 0 and 1. Now, that's in Blender. It uses the range of 0 to 1, but you can use whatever range you want as long as you agree with the computer on what the range is going to be. 0 to 1 is one option. You will often see a 0 to 255, which uses integer numbers. So 0, 1, 2, 3, 4, 5, 6, 7, up to 255. That's a very common, it's called an 8-bit number. Why 8 bits? Again, the computer deals in ones and zeros, and a nice small integer that gives you 256 possible values is an 8-bit number. And that just means there's 8 zeros and ones, and if you take all the possible combinations of turning those zeros and ones from 0 to 1, you will get a number that goes from 0 to 255, which means 256 possible values of red or green or blue. Keep in mind that 0 is a value, so that counts. So that's like one value, and it goes up to 255. Very common that you will see, instead of these being from 0 to 1, you will see from 0 to 255 using an 8-bit number. So you just tell the computer for red, I've got 8 zeros and ones, and we're feeding that to the computer, and it knows, okay, well, that red is, 208 is my red value. It's really nice now that we can specify any color as 3 numbers. The challenge is we need to figure out what range we're going to use. Here we're using 0 to 1. Very often you can use 8 bits, 0 to 255. You can use 0 to 3 million if you want. But there are some standard formats or standard ranges that computers use, and you just got to make sure you're using the right range when you're specifying these RGB values. But very, very important that you understand that, all the colors here come down to 3 numbers. You just got to figure out what the range of those numbers is, but at the end of the day, it's 3 numbers. So now we've got our image, and we can specify to the computer any color in this image merely by giving it 3 numbers. So let's say I want to go down here. Down at the bottom here, I want to get into this and specify the color. And if you look at this, you can see, hey, wait a minute. This really nice, beautiful image, it's just these little blocky things, right? They're little blocks. Every image, every computer image is comprised of these little blocks. And these blocks are called pixels or picture elements. And what we do is we specify for each pixel one color, one value of red, green, and blue. So I can go over here to my eyedropper and I can click on this, and up here on the right, that is a value of 247, 189, and 116 for RG and B. Every image is made up of these little pixels. It doesn't look that way if you look from a distance. That's because this is a high resolution image. So what is the resolution of this image? Well, if you look on the upper left here, you can see that this is a 2000 by 1250 pixel image. What that means is if you count, go in here and you count every pixel, and you can't see the pixels here because they're all about the same color, but you count there are 2000 pixels across, horizontally across the image. And if you go up and down, there are 1250 pixels. So if I zoom in, I'm seeing individual pixels, but actually across the top there's 2000, and down and vertically there is 1250. So if you multiply 2000 times 1250, you can see there are over 2 million pixels in this image. That's why it looks so smooth, but all you have to do is scroll in. You can see these are actual pixels. And again, each pixel is one color. It's not a graded color. It's not a range of colors. It is one color. So really what we're doing is we are telling the computer For every single pixel in this image, we are giving it 3 numbers: a red number, a green number, and a blue number. And in the case of this software, it's working with 0 to 255. So that's extremely important to understand, that behind every image is basically 3 sets of numbers. Red values, so for every pixel I need red values, a number for the red values. For every pixel I need a value for the green value. And for every pixel I need a value for the blue. Which means if I've got 3 million pixels or something in this image, I've got 3 times 3 or 9 million numbers to define the red, green, and blue, okay? So there's a lot going on in this, but really at the end of the day, it just comes down to numbers, right? The computer is stupid. It only understands numbers. In this case, for each pixel, there are 3 numbers associated with it. So now if you think about it, this image, which is just, millions of pixels, like 2000 by 1250 pixels, it's kind of like a spreadsheet, right? It's just numbers. Like each image is composed of pixels, and each pixel has 3 numbers associated with it. So it's kind of like a big spreadsheet. So for example, the red components, you'd have like 2 million across the top here, and then 1250 up and down. But here's just a small portion of the top left corner of the image, and we've got these values for the red component of the pixel. And then there's another one. I go down here and I select the next one is green, and it shows the green values. And then there's blue, which has the blue values. And they're all going to be different probably. But you can see that it's kind of like, to the computer, this is nothing more than a big spreadsheet that's got, for each pixel, it's got 3 values: red, green, and blue. So now you can think, okay, well, it's just numbers. Wouldn't it be easier, because we humans look at these numbers and your brain explodes. Wouldn't it be nicer if instead of numbers, we could have shades of white and black and gray, right? So for example, if I could convert these to values of gray, then I could have, instead of 3 spreadsheets, I could have 3 images, like a red image, a green image, and a blue image that was just shades of gray. So I could look and I could visually see, where there's white, that means there's a high value of red or a large component of red, and then where it's black, it's a 0 component, right? So I can have 3 images now that are basically a visual version of the spreadsheets that have the red, green, and blue components. So here what I've done back in Blender, and I've taken here on the left a rendered image. I've converted a sphere and a plane that we built in Blender, and we put some materials on it, and I've converted that to an image which is called rendering. So now I've got this rendered image, and you can see I've got a red sphere and a blue floor. So what I've got here on the right is the images that are basically the 3 spreadsheets that define, on the top is the red component, in the middle is the green component, and the bottom is the blue component. And basically it's just taken the spreadsheet of numbers and converted them into grayscale images. So as you can see, I've got a red sphere, which means you would expect white in the red component image, where this sphere is. And I look over here in the red component image, and you can see the white is where the red sphere is, and here is blue, so you wouldn't expect a lot of red. In the middle, I've got the green component. You can see I've got red here and blue, but I don't see a lot of green in here, which is why this is very dark. Down here, I've got red, green, blue on the bottom, and as you would expect, the blue floor will have white where the blue is and black where the red is, because this tells you how much blue is in the image, and it's only where that blue plane is. So now you can see that each image is defined by these 3 spreadsheets, or these 3 images that are basically grayscale. They go from 0, which is black, to 1, which is white, or 0 to 255. But they're basically just gray, and they define to the computer how much red, how much green, how much blue for each pixel. So the computer looks at this number 1 pixel way up here in the corner and says, black because there's no red. This next one, black because there's no green, and black because there's no blue, and so on. So actually, each image that you see is basically a file on your computer, and it's comprised of these 3 sets of data that can be put together into these images so that we can understand it. But at the end of the day, it's just these 3 spreadsheets of values that the computer uses to say how much red, green, and blue. So this is a really important aspect of images and colors. You need to understand this. We know now that each image is comprised of these 3 what I call spreadsheet images. These are called channels. Unfortunately, the terminology in the computer world can be kind of confusing, but these images or these spreadsheets are called channels. And this image is comprised of putting these 3 channels of information together. But when you think about it, this is just a file on your computer, this image. So it might be a JPEG or a PNG or whatever, but it's just a file of all these numbers represented by these images. So if you think about it, this gives us R, G, and B values. But if we're working in the 3D world, right, we could add to that file, we could add more numbers if we want. So for example, we're working in the 3D world. Maybe there's some information about our scene. When we rendered this image, we could add some information in that file about our scene. So let's take a look at some of the things we could add to that file, because really at the end of the day, it's just numbers. So instead of just these 3 spreadsheets, I could have 25 spreadsheets of data and pack it into that file. As long as the computer knows what to do with that data, we can tell it anything we want, all right? So let's look at some other things that we can use in these images to give us data. So here I'm in my simple scene. I've got a red sphere and a blue floor. And let's say that aside from when I make the image, when I take a photograph of this, what we see right here called rendering, when I take a photograph, of course I'm going to store the red, green, and blue values of each pixel that gets put into the image. Let's say I want to add some more information. So we're in a 3D scene, which means that there are 3 dimensions, right? We've got X, which is left to right. We've got Y, which is front to back, and Z, which is up and down. So what if I wanted to also store, when I render this, when I make an image, I wanted to add some information into the image to tell somebody else, oh, by the way, when I did this scene, the distance from the camera where we're looking to each point on this object, I'm going to get that number. You know, maybe it's 5 feet or 5.3 feet or 2 meters or 2.6 meters. Whatever that number is, I'm going to, for every point in this scene, I'm going to add a number, another, what's called a layer, another set of numbers to that RGB that defines for each point in the image how far away the object was. So now I've got another spreadsheet called distance. So I've got my red, green, blue, distance. Again, it's all just numbers. So now I can pack another set of numbers. This is called a layer, which is distance, which provides information about the scene. So now I've got RGB plus distance. Again, it's all in the same file. And the sky is the limit. I can do all kinds of things, getting more information about this scene and pack that data as a separate spreadsheet into the image file. In this case, distance, each distance is just a number. How far you are from the camera to any point in the scene. So we're closer right here to the camera, and here we're a little bit further away, and in the background we're very far away. So the takeaway, every image is pixels, and an image is basically an information container that describes information either about the image itself or about anything else you want to add onto it. And when we show an image with all its pixels onto your computer monitor, keep in mind that the computer monitor also has pixels. If you take your smartphone out and do a close-up of your computer monitor, you might see something like this, where you've got blue, red, and green, and here we've got white and blue. Basically, your computer monitor has a lot of LEDs that basically emit red, green, and blue light. And you map the information in the image to those pixels on your monitor, and that's how you get the different colors. So there's nothing rocket science here, it's just a bunch of numbers with pixels. So I hope this helps. In future videos, we're going to be getting more into some of the additional aspects about 3D computer graphics. We're going to be looking at surfaces and lights and rendering and compositing and a bunch of other things. So if you like any of these videos, I encourage you to hit the like button, subscribe, hit the bell notifications. Most of all, please let other people know that we're here so we get some views. Otherwise, take care. Have a really good day. Thanks.